Hi there, it's nice to see you again. This video is on evaluating the definite integral from 0 to 5 pi over 6 of sine to the fourth x cosine x dx. And in this one we're actually going to also do our substitutions for our endpoints of our integral, our limits of our integration, as well as with the rest of the integral. So remember to look at evaluating a definite integral by the fundamental theorem of calculus. If we have a continuous function on a closed interval, then the definite integral from a to b of f of x dx can be found by finding an antiderivative of small case f of x and calling it capital F of x, and evaluating that antiderivative at the upper limit of integration minus evaluating that antiderivative at the lower limit of integration. Now what we have in this specific situation is our definite integral from 0 to 5 pi over 6, and I have sine to the fourth x cosine x dx. So I can rewrite the meaning of sine to the fourth x. Remember, that means that your sine of x is being raised to the fourth power, and then we have times cosine x dx. So with this, we need to do a U-substitution in order to integrate it. We are going to let U represent what is being acted on. So sine x is being acted on by the power of 4. Sine x is going to be what we represent U with. And then remember, we also need to figure out the differential du. Well, the differential du, we first think, well, what's the derivative of sine x? The derivative of sine x is cosine x, and then dx. And then when we look back, we also have our endpoints of integration. Well, if u is equal to the sine of x, then when x is equal to 0, that gives us that u will be equal to the sine of 0. And in this case, we get u is equal to 0. And when x is equal to 5 pi over 6, that gives us that u is equal to the sine of 5 pi over 6. And we get that u is equal to, well, the sine of 5 pi over 6 is positive 1/2. So we will make all of those substitutions. We now have the integral from 0 to 1/2 of u to the power 4, and then remember the cosine x dx both go and get replaced by the du. Now integrating this, we're going to use our power rule because we have a letter base to a number power, and the number power is not -1. The general power rule for integration, we add 1 to the exponent, 4 plus 1 is 5, and divide by that, so divide by 5. And we don't put the arbitrary constant when we have a definite integral. We just show our vertical line for evaluated at, and our lower limit within the u values is 0 up to the upper limit of integration, the 1/2. And I can write this u to the 5th over 5 as 1/5 times u to the 5th. So it's 1/5 times, put in the 1/2 for u and raise that to the power 5, minus 1/5 times, take out the u and put in the 0 and raise it to the power 5. So this next gives me 1/5 times 1/2 to the power 5 is 1 over 32. And then minus 1/5 times 0. And so I get 1 over 160 minus 0 is 1 over 160. And that is the value of our original definite integral from 0 to 5 pi over 6 sine fourth x cosine x dx is equal to 1 over 160.